Nathaniel, and today we will now do question 4 of step 3 2021. From the bold letters you can see is actually a vectors question, but for purpose question's sake we're going to treat it as a trigonometry question just to make things easy. So how to show that m bisects the angle between A and B? Well, it's quite simple, so we use the vector form for angles. A equals to I cos theta plus j sine theta. And just for fun, we're going to assume that everything is in 2 dimensions because it doesn't matter which dimension you are actually looking at. Anyway, this question is supposed to be in 3 dimensions, but just for fun, we're going to assume everything in the question is 2 dimensions and pi is actually just a line. So, if m bisects the angle between A and B, I cos theta plus j sine theta, I cos phi plus j sine phi. So, well, m equals to the cos theta plus cos phi over 2 and then j sine theta plus sine phi over 2. Now, we're going to do something fun. We're going to use the sum product formula. So cos theta plus cos phi over 2 becomes cos theta plus phi over 2 cos theta minus phi over 2. Now you might be thinking, hang on, you're making the equation more complicated. Well, I am making the equation more complicated. It's just that it will become simpler very, very soon. So here I am just using a sum product formulas, and look, these I and j components share a common factor, cos theta minus phi over 2. And this factor is actually the modulus from the origin, which actually makes everything easier because you can see there's just the cos and sine. Whoops. Everything just cancelled. Well, looks like we just proved question 1. Let's see. The vector C also has unit length. The angle between A and C is alpha. The angle between B and C is beta. Both angles are acute and non-zero. Just for fun, we're going to assume everything is 2 dimensions. So we have A, C, B. And then this angle is alpha. This angle is beta. Show that the angle between phi between A1 and B1 satisfies this. Well, this is phi. Well, what we are gonna do? Well, it's actually simple. First, we have to find A1.C equals to 0. So this is A1. And since A1 is perpendicular to C, the dot product, using the dot product property, this means that A1.C equals to 0 because they are perpendicular. And mod A1 is actually the dot product of A by itself. Because of the square root. Now, the mod A1 is basically just distance, so sine alpha. Right, it's just basic trigonometry. This is sine, this is cosine. So show that the angle phi between A1 and B1 satisfies this. So just for fun, cos phi equals to -1. Cos alpha plus beta minus cos alpha cos beta equals to negative sine alpha sine beta, and that sine alpha sine beta is -1, which makes us have proved part 2. Let M1 be the projection of M onto the plane through the origin perpendicular to C. Whoops, we had just cleared the diagram. So C, no, this is C, this is B, this is M, let's say M is here, and then we have A1, M minus 1, B minus 1. So that M1 bisects the angle between A1 and B1 and only if alpha equals to beta, which is obvious if you think about it, because if alpha equals to beta, then M becomes C, and then C will then become 0, which in that case doesn't matter which direction because the direction of the point is indeterminate. So, which effectively proves our point. So, the other case will be when cos theta equals to cos alpha minus beta. So, if you calculate cos alpha plus beta equals to cos alpha minus beta, then you have 2 sine alpha sine beta equals to 0. Well, then that means A must be B or B must be A, in which case A equals to B in this case. And either that or A must be opposite B or B must be opposite A, which again in this case means that cosine theta equals to cosine alpha minus beta. These are the only cases where this is possible, and therefore M bisects A and B. See you in another maths video.